When incorporating wireless functionality into your system or product, such as this wireless LAN network processor, validating proper operation or troubleshooting when things go wrong can be a challenging task. A mixed domain oscilloscope can prove very valuable in this task. It allows you to view analog signals, digital signals, including buses, and RF signals simultaneously and time correlated. In our case, we're looking at 4 different signals: the power supply voltage to the module and the current through that power supply. We're sniffing an RS-232 bus between the module and the host microcontroller, and of course we're looking at the RF output at 2.4 GHz. Our wireless LAN module is in a test mode where it's transmitting about 1 burst per second. We're using channel 1 to monitor the power supply voltage. In order to see small variations on the supply voltage, we've dialed in an offset that's equal to the supply voltage, in this case 3.6 volts. That allows us to use just a 20 millivolt per division sensitivity so we can see small variations in the supply voltage. Analog channel 2 is used to probe the RS-232 bus, and the bus menu is used to set up the parameters for the RS-32 bus settings. Channel 3 is being used with a current probe to monitor the power supply current. And of course the RF output is being connected into the spectrum analyzer input. We're particularly interested in activity around the RF transmission. So you use the trigger menu to set up RF power as our source for triggering on a rising slope minus 30 dBm. That allows us to trigger on the rising edge of the RF burst from the wireless LAN module. And because the RF burst is occurring so infrequently, we've also set the trigger mode from auto to normal, and that will ensure that we only get acquisitions when this infrequent RF burst occurs. After adjusting the horizontal scale to set up the duration of record that we want to look at, we use the acquire menu to set the acquisition mode, in this case to high res, and the record length, in this case to 100,000 points. This gives us a resulting 100 megasample per second in each of the waveforms for good resolution. After doing a single shot acquisition, let's take a look at all the waveforms available. We've got the power supply voltage, the power supply current to the wireless LAN module, the RS-232 waveform and its decode, and this is the RF amplitude versus time, and this is the spectrum of the RF signal. The RF spectrum shown occurs at this location in time, indicated by this yellow bar. We can move that anywhere we want within the acquisition to see what the spectrum of the RF signal is doing at any location in time. This can be especially handy to track down problems that occurred during a burst, possibly due to other signals in the system. You can see it's quite obvious that the power supply voltage dipped during the RF transmission. If we want to see how much that dip is, we can quickly look at it with a pair of cursors. We can actually see the power supply dip by about 24 millivolts when the RF transmission came on. If we switch the cursors to channel 3, we can see that the current went from about 81 milliamps to 174 milliamps during that time. So that 90 some odd milliamp change in supply current caused this 24 millivolt dip in the power supply. You may also be interested in validating the delay between the activity on the RS-232 bus and the start of the RF transmission. Again, moving the cursors, we can see that there's about a 515 microsecond delay. Of course, you may also need to take a look at the actual data being sent on the RS-232, and we can do that by simply zooming in and panning over to that portion of the acquisition and observe the decoded data from that RS-232 burst. The mixed domain oscilloscope can give you a time-correlated view of your analog signals, such as voltages and currents, your digital signals, including buses, and your RF signals, all in the same display. This dramatically simplifies the process of validating and troubleshooting the integration of wireless devices into your designs.